What's up guys, my name is Harshal Mavani and in this video we design a program to better illustrate the use of the static keyword in Java. And as always, we try to do this in 5 minutes. So let's get started. Whenever you're prompted to demonstrate the use of a keyword or a concept in Java or any other programming language, always start off with a programming example. So let me just get this program up. I have a simple program over here which we will be using. We'll modify it soon. The class student will be the class under focus. Let's say that we'll have our fields and static keyword and all of them defined over here. The main class will simply have the main function, and from here we will instantiate the student objects. So if I'm trying to demonstrate the use of the static keyword, let me have a static variable. Let me call it id generator and let me give it the value 0. Also, I want each student to have his or her own ID and own name. Now, let's try to implement what we understood in constructors. So we have student. I'm talking about a default constructor. In this default constructor, what I do is ID is equal to idgen plus. Now this statement over here will make sure that each student, whenever created, will have a unique ID to himself or herself, and these IDs will never collide or will never match for two different students. So how exactly is that happening? If I want to invoke a constructor, I know that I will simply instantiate the object. So I'll simply type out student s1 is equal to new student. Let me just copy paste student s1, student s2, and any guesses? Of course it's going to be s3. I have these three over here. Before we try and execute this, let's just have a dry run. When this statement is executed, we know that the constructor is going to be invoked. Inside the constructor, I have id is equal to idgen plus. Id being a non-static variable and idgen being a static variable. Since it is a static variable, this class as a whole shares only one copy of the idgen, and all the instances of this class will have their own copy of id. To visualize it better, let's just try and draw it. So we'll have student s1, student s2, and student s3. S1 will have its own id field, s2 will have its own id field, s3 will have its own id field. But idgen is not local to any of these. Assuming these are memory spaces, then there's one memory for id of s1, one memory for id of s2, and one memory for id of s3. Let's say one memory, just consider it to be some abstract unit. But idgen is not stored within these spaces, it is somewhere else. So all of these may access idgen, but idgen is not local to any of these. There's only one copy of idgen. So when the first statement executes, the flow goes over here. id is equal to idgen plus. Idgen was 0, increments, idgen becomes 1, and hence id will store the value 1. So actually, instead of getting 1 2 3, we'll have 0 1 2. But the point to really take into consideration is that we'll have idgen being continuously incremented and being added to id. This id is a instance variable rather than a static variable, rather than a class variable. So we'll have the output 0, 1, and 2 over here because the idgen plus takes 2 steps. So in the subsequent iterations, we'll see the value being reflected. So let's try and run this program. We have java c space student main.java and java space student main. So we have s1 id is 0, s2, s3, 1, and 2. So that's it for static keyword. Thank you so much. Keep watching.